Good evening, everyone. My name is Howard Johnson, and I am the lead developer for the Talawa app. And this is going to be the code review for this evening. So basically, I'm just going to be showing you the ins and outs of the general flow of the project and how you can traverse it on your own. So basically, I'm starting off as you would start off with any other Dart project or Flutter project, that is. Starting off in main.dart. So with this now, what you're going to be stumbling upon is the use of provider. Now, provider is used thoroughly through this application to handle a lot of state management and the like. If there are any questions on that, feel free to ask so later on. But just know that there is use of multi-provider, so this is use of more than one form of provider. And this is used from as it pertains to authentication, user specifications, and the like. So um, from there, you can see that there are several folders to be aware of. I'm going to start off with the controllers first. So basically, this if you're familiar with the MVVM pattern. So basically, this is a hybrid of that. So I'm using both the MVVM and MVC in this. So for the controllers, you can see here that you specify for the activity controller, and activity controller just means that if it is that you are familiar with the app, there's the activity screen. This is basically handling all of the API requests that are related to that screen. So from things like being able to get the activities, get a single activity, CRUD operations, pretty much. You can find them here in the activity controller. Similarly, if you were to go over to the auth controller, without need be, you can say that this handles authentication. So being able to be able to get the user, do logins, registration, and the like, you can find it here. And exception handling for this is done in its simplest form, so be aware of that as well. There's no complexities here. And the same is true for the rest of the project as well. Um, the node controller, this is specific to the messages you would consider them as in the project. So this is one of the more unique controllers in that it uses a implementation of socket. Now, if you're familiar with socket or socket IO from JavaScript, this is just basically handling streams. Again, if there are any questions, you can ask them after. But there's a level of uniqueness to this because of that factor. And same thing goes through here, being able to handle join persons, being able to join the rooms, send messages, receive those messages, and the like is in here. For responsibilities, same song and dance. We have the crowd functionalities for responsibilities, being able to get them, um, create them, and so on. And same thing for users as well. Specifically for users, is separated from general authentication because you might be wondering what's the difference between authentication and users. There's some specifications that are made here that I'll get into later. And yeah, that's pretty much it for controllers. Getting into here, this is a middleware that needs to be rerouted back to somewhere, so I'll get into that later. But let's go on to the models folder. So with the models folder, this is basically just defining what each and every model or entity that's related to this project. So the same thing from the controllers are directly related to these models. So defining what is considered as an activity. Same thing for notes, responsibilities. For tokens, this is something that is taken into regard for when it is that someone actually logs in. So this is a part of the authentication process. That's what tokens is for. I'll specify for that later. And as you know, user. Moving on, we have services. So this is actually done by an auth developer. that I had incorporated work from. But basically, this just handles for a particular user to know if the device is connected to the internet or not. So you know that if it is that they're supposed to be receiving a message, the system would have to check for that first, and then you know how that goes from there. And for preferences ties into the notes model that I had shown you before. So basically, when it is that you logged in for the first, well, before you even log in for the first time, your token is set to null. And if it is that you're going to log in, that token is then stored on the phone. Now, it's a situation where if it is that you actually leave the app or close the app, if it is that you were to reopen the app, it's not a situation where you have to keep relogging because it's persistent in that sense. That's what preferences is used for right here. And utilities is a slight variant from services in that it handles some basic general information for the application. So for API notification, this was supposed to be built to better handle exception handling for APIs. So that's something that's to be worked on. Global. This is basically where global variables are stored, where the base API is concerned. So this is for any globalization. All of this is supposed to be tracked within this file itself. UI data. This handles theme data as it pertains to what colors, themes there are, the images and assets that are used in the application, and everything else from the like. And validator. This basically handles a lot of the form validation. So you have here, as you can see, for validate email, this function right here handles how emails are processed using a regular expression. You can see, and then from that, if it is that it is a plausible email, it returns the appropriate thing to the form so they can get the appropriate message. And the same thing is for things like password, the confirmation for that, titles, everything. All right. And as I said, it tends from the view MVVM pattern. So you can see that there are some view models here. It's just specific to the forms that are throughout the actual application. So you can see here there's an add activity view model, an add responsibility view model, a login and a register view model. From there, I know we actually get into the views themselves. So can start off here with the activity detail. Now the activity detail that file handles is the actual individual activity itself. So say for instance you're on the base app and you see the list of activities. When it is that you actually go ahead and click on an activity, this is the screen that you see. So this, as you can see, is a stateful widget. Outlines all of the functionality for that, how the page is structured, scaffolding, everything, and like for add activity, I tend to move towards widgetizing a lot of the other pages as opposed to the add activities. So you might realize that these pages might seem bare, but it's only due to the fact that it's been widgetized. So, and I'll show you the actual widgets themselves, as you can see down here. Same thing for add responsibility. Contact page needs to be widgetized. The actual home page, so that's the page that you actually land on upon logging in. Login page, it is that they're not supposed to be found. Say for instance, if it's a unknown route, the responsibility page, and this is a demo page. It's removed. Yeah, that's it for pages. Now we get into the widgets. Now we can see that there's a specific folder for forms. So this basically handles all of the forms that you would have seen that were widgetized in the other pages there. So we have an add activity form, which handles the processing adding activity, add responsibility, edit activity form, edit responsibility form, login form, and the register form. And then the widgets themselves. Now, a lot of these widgets are generalized. This project first started off from a theme. So a lot of these widgets that you might be seeing here as it pertains to like common scaffold, switch, all of these were repurposed as need be for the app. Some of them custom, like say for instance, snack bar and date form picker. So if you see when it is that you actually add in a activity that's a specific unique feature, not just a regular form. And yeah, pretty much this is where the bulk of the code is within the views themselves. But yeah, that's pretty much it for the actual file structure of the project. Before I go on, are there any questions? May feel free to ask.
Howard, this is Peter. At some point, could you go through like a workflow, like how the login works, how the adding
Okay.
activities work, and then possibly also do a screen share of the actual application as well, so that people can see it and see how the code matches the screens. That'd be good, I think, too.
Okay, no problem.
Hi, Peter and Howard, Andre here. I noticed there's a test folder as well below the lib folder. Is that
Yeah.
currently yours?
No, that's currently not in use as of the moment. That's the default test folder that comes with all Flutter projects.
Okay, but that would be expected to be the location for any test built out this.
Yes, yes, yes.
Okay, cool.
And that's one of the milestones that we plan to incorporate into the system to have appropriate unit testing for the represent functions in the system.
Right. Okay, cool.
So I'm just setting up here. Yeah, so just give me a moment while I get this up.
Howard, while this is loading, could you go over some of the challenges you faced with the project? And that means fill a little time.
Okay, sure. So some of the most noteworthy challenges that I can recall while working on the project is state management and the use of using custom third-party implementations. So let me start off with the state management as first. So as if you're not familiar with Flutter, there are many implementations of handling state management. My problem was basically understanding which one would be the best approach, which one would be the most fluid one, and basically be better for future code. So comparing, some of them might have left my mind right now, but with the use of provider, it's basically a one size fit all type thing, and the way how it works is a hierarchical implementation, and there's a whole methodology to it as well. So that in and of itself is something that I had to go through personally, and also with the help of Serbane and others. So from that, I could see the apps coming up now. Yeah. So from that was an experience in and of itself. Other than
Could you
that,
just remind,
what's
could you
that?
just remind me where the state management, where it's handled
Okay,
currently?
sure. So as I said, that's something that's it's a hierarchical thing. So imagine a tree. Let me get back to main. So yeah, right here, it's being handled right in the main function right here. So imagine, as I said, from a tree you have the root, and then going up you have the various nodes, right? So with provider, you basically instantiate it within the base of the application. And say for instance, you may need a particular resource. Say you need a activity to be where activities are supposed to be. Like say for instance, activity detail. You might need a particular activity for that. So there is where you would instantiate a provider for that, a provider instance for that. And that provider instance is directly called right back from this main function right here. So it checks to see that if everything is in a line, if it's being called from something else, how many instances from that, to for redundancy issues and stuff like that. As I said, it's a whole methodology that you'll have to get into, and I don't mind helping you through every step of the way. All right?
Hey Howard, DeAndre here.
Yeah.
Do you mind just giving like a brief walkthrough of let's say I'm making an API call, or I could just ask if little bit if it would be the process based on my experience in terms of utilizing different classes and stuff that based on how the provider architecture is set up.
Okay, no problem. Um,
Yeah.
Hold on, let me just get rid of this. I'm using free software at the moment, so trying to see if I can get the screen on here. Stop sharing and reshare. So invitation. Let's go here. Everything seems to be good so far. Let's go ahead and share. So you guys can see the screens, right?
Yes.
Okay. So I guess I'll start from the actual login. Just log out here real quick. So from this page right here, let me just go over to the actual view for this. So something like this.
So you'll just be doing a walkthrough of like the login implementation and or something to that effect.
Yeah, basically.
All right.
Login page. Okay. Right, so basically this is what the login page looks like. um, have some supplementary code right here for animations that's handled right here. I realized that Laurel is actually here. Laurel is actually the individual that I was making reference to that helped me with some of these screens as well. So again, thank you for that, Laurel. But Cupertino is for iOS support, which isn't currently being supported as of yet. We'll get into that. If will we be getting into iOS support for this run, Peter?
Possibly we'll have to talk with the mentors about that, but that would be
Oh,
ideal eventually.
okay. All right. So basically, use of variables right here, handling a lot of the animation support, the actual widgets themselves. Oh, again, basic Flutter um, boiler code as it pertains to handling with stateful widgets. With a little bit extra, referring to ticker provider state mixing. That's for the animations that you see when you go from page, well, from tab to tab, that is. Just navigate it, yes. So say for instance here you create account, you can see that right here creates that. But yeah. Login screen in and of itself being a widget. Go over to that right there. So as you can see that along with provider itself. Provider itself isn't hierarchical because it wants to be. It's just following the standard from which Flutter and in itself Dart follows. Because everything in Flutter and Dart is hierarchical. So everything is a widget basically. So going from that you can see there's a center widget, and from that for the child for that center widget is encapsulated with a container and so on and so forth. Same thing for the registration screen form. So if we were to go over there, same thing you'd see over here. Separate functions right here for go to login. You can see that there's some specifications outlined here. These are basically the variables for the parameters for these functions. So it's for the zeroth index, duration being 600 milliseconds, and the type of animation that it's going to be using, which is curve bounce out. Same thing for the sign up and the actual build. So within every screen or widget, it requires a build function to actually bring everything together. Um, a lot of the variables are designed here in relation to the animations. There's some futures here that Laurel had put in for the various animations as well. Load the main screen itself, though, which is actually this screen. You can see all of the definitions for the various widgets here, and so on. So I'm gonna go ahead and do a login. So if I remember the credentials right. Actually, let me go ahead and do a register. Right. So if you can recall from the validations that I've showed you before, this is basically it acting right now. So yeah, hey John. So You can see as a new user, we'll be moving over to this page, widgets, the home page.
Hi, Howard.
Yes, yes.
I know you had walked through it quickly earlier on, but I think it would have been valuable to show like the sign-in route that would have been called.
The signing route.
Right.
Go to that. Or the actual route itself.
Right.
This is in relation to you asking about the API call, right?
I think someone had asked about it, so I think they wanted to see how that would have been
Okay.
actually enacted.
So this actually heads over to a thing there, I believe.
Hey, Howard, can you hear me?
Yes.
It's Ryan.
That's right. What's up?
Are you? I came in a little late. I'm wondering if you're running a local server or is the server hosted online at the moment?
So this server is currently on Heroku.
Okay, thank you.
Yeah, no problem. So for the sign, this is for
You
this
could
is the
correct.
form actually.
Okay. I was saying you could correct me if I'm wrong, but I believe the base route to that Heroku instance would be found in the utils globals file.
Yes.
Okay.
So going over to the login form here. So this is where the actual login is done, and this is the implementation of provider. So you can see that there's an instance of provider right here. So and it's of auth controller. And as again, I'll go through the actual nitty-gritties of these, but you can actually see the login being called right here. What I'm going to do is I'm going to shift click this to actually navigate to where this function is being declared. And I'm going to show you here as well. It's the controllers. So we're heading back to the controllers folder, auth controller, right? So here is where we actually define the login process. So what we have is I pass the build context here, and I'll explain the build. Well, if anyone wants me to explain the build context, I'll do that at a later time. But here is a use of the view model of user, which was passed to the function back in the form that was shown previously. And this is an asynchronous function, which is to return a future string, off string, that is. So first we start off in creating the actual request that we'll be sending over to the API. So for this request is just a simple one. We're just making an email and password a part of the map, and we're using the variables that were passed over in the parameter, the login view model parameter. All right. So with that request now, we create another map to handle the basic JavaScript JSON based request that we'll be sending right now. And seeing that we're going to be handling all of these via JSON, we specify that the content type is going to be of application/JSON. All right. Now we have a simple try block here. Well, not simple, but you get me. Creating a final response, basically awaiting a post request. So this is the actual request in and of itself right here. So this request is using the base route. Now the base route is as one of first, as I said before, there within the utils global folder. This is actually the base route that's being called right here. So Talawa /-API at heroku.com. Going back to the auth controller now. So that's the base route for this. Going to the actual route itself that's defined in the server. So /auth/login. make the header that we defined up here, the body being a JSON encoding of the request body that was defined up here, and we're expecting this request to be done within the next 20 seconds. This is basically what this stands for. All right, following so far?
Yeah, I'm following.
Got you.
Okay. So after that, we do a basic switch, because given that this is an asynchronous function, this piece of code is fired, and then we await a response for that. This is what this await keyword is for. So after we get a response from the server within the 20 seconds, mind you, that request can be anything. It could be an error, it could be successful. This is where we actually define what the application does upon that fact, right? So we set up a switch right here to basically say the response that we received, if it is that it's returned as a, what I could actually do is log out and then put a breakpoint to actually show you what actually happens here, right? So we go back to login. We're going to do that. So you see the breakpoint stops here. Now let me just hover over the request body. So you can see the request body is set to email with the email that I just supplied it, and the password being test123, right? Now this response is stored here. Now the server had actually returned a lot of information here. So you can see that there is a token returned for the actual body. The request itself, you can look into a lot of data that can be useful for us. But what we're really concerned about is if the request was successful or not. Now, for a lot of HTTP and HTTPS requests, 200 is what we use to actually define if the request is successful. So we say in the case that it is 200, which it is, it's going to decode the body, which was sent over into the request body, and then actually parse the token that was sent. So remember that whole token functionality that I was showing you before, this is where it actually comes into play. Because I don't know if I should get into it now, it might be a little bit too much. I'll get into it later. But basically understand that this is an integrity issue that's being handled right here with the whole token. So the token is then transferred into actual, we move down actually. So, okay. So to hover over the token right now, you can see that the token is stored right here. That was from up here. Right. Going from that now, what we try to do is save the current user ID. So this is where the persistence happens with the preferences file that was made. So from that now, the actual user ID, now this is the 13th user. This is a sequential process in saving user IDs. So this is the 13th user based on what the server is tracking. And that is going to be stored on this phone itself to say that, oh, that user is logged in onto the phone. So if you were to close the app, reopen the app, it's going to relog you in as that user. And from here, you can see that a navigation of context, which is why we had brought over the context from the form that was sent. We need it to be able to call this implementation to be able to return us to the home page, because seeing that it's successful, we need it to return us to the home page so we can see the dashboard and the like. And if you need any debugging, you can say that, oh, users logged in. Now, say for instance, the request was not successful. These are the exceptions that supply the subsequent message to say that the request was successful. So say for instance we got a 401, you can see that we get a scaffold of show snap bar, and a snap bar is just simply, if you were paying attention to when we had actually logged in, you saw a little thing come up that said user logged in, user registered successfully. Same thing happening here, but just basically telling you that the unauthorized login. Or if it's a 403, it's a forbidden access to resource, and all of them that are right here, they all have their unique use cases and things that you have to give account for. And the same process is for, say for instance, if you're going to register. See, the register is a little bit more complicated because it's taking some more data. Say for instance, you need a first name, last name, email, and password for this one. And as you see, there's a register view model to be able to track that. Basically, with all of this code, it might be seeming like a lot, but this is a very good way to make sure that the code is understood. Say for instance, if you were to hand off to another developer, as is what's happening right now. And yeah, it makes the whole development process a whole lot easier. But just go through this. Display actually. And we're back where we were, right? Okay. Utils. Close all of that. So, Peter, you want me to go through the entire process, or you taking questions?
Take questions and then let's use that as the guide as to which way to go.
Okay. So, guys, any questions? Anything that's unclear? None? Okay. So I wanted to explain the whole token aspect. Oh no. Yeah, I'll explain the token aspect. It's more simpler than the socket one. That is. Probably can do that at a later time. But so preferences. Well, let me actually start off with the token itself. So with this right here, the token essentially is a part of a larger scheme of things, which I'm just gonna throw the abbreviation at you right now, called JWT. Now that stands for JSON Web Token. Essentially, what a JSON Web Token is used is to basically ensure that there's integrity between, well, for this case, the server and the users that are communicating at any given time. So say for instance, I send a login request to the server, and I want to make sure that the person who sent that login request is the person who is supposed to send that. Say I don't want just a random person to be doing something admin related. That's where you can say, all right, you can have an implementation for JWT, because what happens is that unique information about that person is sent along with that request to the server, and based on that, if it is that criteria matches, the request is carried out as need be. So essentially that's what's being handled here. For the JSON Web Token, it's decoded at base 64. These are things that are just standards. So it's not something that you might have to wrap your brain around. It's just standards for a typical JSON Web Token. I'd probably, if it is that there was a, Peter, will you be creating a specific WhatsApp group for this group, or I heard mentions of Slack?
There's a Slack group.
Okay.
There's a Slack group that I've created. I've just invited you.
Okay, thanks for that. But I'll be sharing resources with you as it pertains to things like this JSON Web Token, socket, Flutter, provider methods, all of that. I'll be supplying resources for those things to you guys if you need it. But basically, as I said, it's just standardized things that you just have to get familiar with. It's no long and short to it. But yeah, that's pretty much it. That's happening right here with the token. And for now, I do admit to mentioning all of that. The token is basically being used right now to be handling authentications, given that the system hasn't shown real use for, say, for instance, admin capabilities that I mentioned before. There's no essential implementation for that as of yet. I'm not sure if that might be a requirement for the system going on further, but I'll get in touch with Peter in regards to that. But yeah, that's basically where we are with tokens. But yeah, I do hope that you guys don't view this code as spaghetti. I really did try my best to organize the code as need be. I'll be trying to do a lot more refactoring if it is that it doesn't impede on any work that you guys are doing currently. I will try to see how best I can beat around the bush with that. But yeah, that's pretty much it for the code review. And I wish you guys all the best working on this application.
And on the API side as well.
Okay. Now that's a whole other mess. Okay. Let's get into that and then we close off. So okay. So this is basically the API side for things. It's well, in my regard. So first off, for the actual resources that are being used for the API right now, this is a Express server, and it's currently using a SQL database with the use of let's remind myself here real quick. SQLize. Currently using SQLize for the ORM interfacing with the Postgres SQL server that we're using right now. A lot of terms I know I'm throwing at you right now. I'll explain them in detail soon enough. But this is also mimicking, well, more so mimicking a I would say it would be mimicking an MVC because there are no views here. This is a server, but we still use controllers here to be able to track the actual functionality for a lot of the API requests that are here right now. A lot of these are Git related resources for documentation, but I'll be paying attention to the actual folders that you guys need to pay attention for development anyway. So let me start off with the actual base folder that we're on. Well, we're not on right now. The index folder that's basically the root of this project. So we have a lot of dependencies that are instantiated right here. Express is a JavaScript based framework. So from that, you can see that a lot of these lend from either NPM or custom built things. So first we start off with body parser. Now what body parser ensures is that for any request that's sent to the server itself, that it's expecting it to be in a certain format. It handles not only JSON but a lot of other formats as well, whether it be XML and whatever the means may be. That's what we use body parser for this dependency right here. Cores, Helmet, and Morgan are just middleware dependencies, just handling basic security and rigidity for the application itself. Express itself, as I said, is an Express server, so this is where we actually define that. And we save everything as a constant because we don't want any variables being changed within these. HTTP is defined separately from the application itself because of the implementation of socket that's here. And socket, as I said, is just a stream-based implementation handling the notes feature of the application. For the port, so we set the port default to 7,000 here. If not for the handling on the environment, and the environment tends to be 7,000 anyway. So, all right. So we get into the actual definition of the routes that are here. So for now, currently have 4 routes that are defined in the server. Routes for auth, user, activity, and responsibility. You might see a trend that's coming over from the actual application itself, where routes and the controllers are concerned, and this is where it comes from. Just basically, it's a one-to-one mapping for them in that regard. Albeit that there might be some additions and negligations from that too. But yeah, we have routes for each and every one of those. We implement Helmet to interface with Express. Same thing for body parser, expecting a URL encoded. Basically, ensuring that all requests of JSON can be accepted here. Enabling cores, so this is cross-site or cross-site resources, and we're enabling Morgan right here for basically login for all HTTP requests. Yeah. So there's some more configurations where Express. So all of this that's in the index right now is just configuration for Express. For base route, if you were to actually go to the URL, say for instance, talawa.herokuapp.com, if you were to actually go to that route, you're actually going to be supplied with an index.html that's right here. Nothing too much as it is right now. But say for instance, if we were to actually build out a web variant of this application, this is where it could start. Yeah. We actually instantiate the routes that were defined from up here, and so we basically say that if it is that from these instantiated routes that are set right here, if it is that they're not from any of these, it returns a 404 on default. So say for instance, somebody wants to just like type in a random URL and make our get or post request to it to basically try to do intrusion on the system, it just throws back a 404. Same thing for this right here, but for 500 error messages. And finally, we wrap it up with a listen. So the application starts off listening to all requests that are sent to it on the respective port. Right? So I guess we go into middleware. I guess we're going to sequelize now. So as I mentioned before, actually try and see if I can go to the sequelize website for just reference. So if you guys actually go to this website right here, a lot of the documentation for the code that I have is right here. As I said, sequelize is a ORM, so object relational model. Essentially what that means is basically a bridge between the database and the actual application itself. In this case, the one-to-one mapping is between the database and the server, and then the server to the actual application. But yeah, it basically takes whatever queries or anything database related and brings that over into a more palatable and fluid means of coding. In this case, it's JavaScript, given that Sequelize is a JavaScript-based ORM. And it works well because we're using Express. So first we get into the config. So the config basically is where a lot of the configuration for Sequelize is done. So for Heroku specifically, this is specific configuration, so that Heroku requires SSL integration, the host that it's been on, whatever password that might be, and the username for that. Um, and yeah, this is basically where all of the configuration for SQLize is set up.
Hey,
Um,
Peter, are you hearing me?
Yes, I am.
I have to run, but I see that the presentation is being recorded. Will we be able to access it after?
Yes, it's going to be on YouTube, hopefully by the weekend.
Okay, thank you.
so, all right, we're getting into the actual base of what where SQLize is implemented. So, bear in mind, all this code is automatically generated by SQLize, given that it's a ORM. It basically removes a lot of the groundwork of the one-to-one mapping that it would be usually be taken into consideration when dealing with a database with a server and all of that. So all of this just basically ensures that SQLize makes the connection between the server and the database. In this case, Postgres. SQLize can be used with a myriad of other SQL based databases, and you're free to look into this. But yeah, this is basically automated code right here. Um, Separate and apart from that, though, these more or less can be written by yourself. So this basically is the same models concept from the Talawa application, which was in Flutter, being represented in JavaScript for SQLize. So this is what SQLize uses to be able to identify the represent tables that are on the Postgres server at any given time. So as you can see right here, you have an activity with a title, description, and a date, and there's an association with that activity for the user activity table and the responsibility table. These are models on the Express, but they do translate back into a fully fledged database. Specifications for that will come shortly. But yeah, and as you can see, things like foreign keys and everything are defined here as well. The same thing for notes, responsibility, user, and user activity. And user activity, you can think of it as an intermediary table, like a many to many, if you're familiar with that. From there, we go into
Um, one moment, please, Howard.
yes, yes.
Yes, it's more a question for Peter. But just to be clear, the students are expected this year to be switching out this implementation for GraphQL. So this walkthrough is more so in terms of the approach to building out the API, correct?
Well, it would depend on what the final decision is. I was talking about GraphQL just based on my experiences. It may not necessarily be the right one. And
Okay.
so I think it really depends on the experiences of the mentors and what students feel would work. And like I said, I chose GraphQL for Purdue because of some of the features that it would provide, but that doesn't mean that it's set in stone. We are at the very beginnings of this application, and it's possible for us to flip in whichever direction dependent upon the good guidance of the mentors who have much more experience in this than I do.
Okay, we're just wondering that. Thanks.
All right. So here is the migrations folder. Now, migrations basically track the state of the what the database should be in. So essentially, from starting off with SQLize, you basically don't have a database. What you'd have to do is actually create the database with a name in mind and everything. But from that, you're essentially not touching the database after that point. What this is considered is a code first approach, right? So with a code first approach, we talk about a concept called migrations. Now with a migration, basically it tracks whatever updates or creations or deletions that you want to make to a given database. So as you can see, there are like one, two, three. There are several migration files that you see right here that are basically time stamped to ensure that there's some form of chronological order. But essentially, what is stored within each of these files are the scripts that would be used to actually be creating a table. So you can see actually here, we can see return query interface create table, and it's going to be creating a table of users. Now within this, and you can see all of this is JavaScript, more so JSON, but you can see all of the parameters here are defined for the user table. So all the way from ID to some supplementary columns that SQLize provides, which are created at and updated at. This is for auditing purposes. But yeah, that's basically what you're going to be finding in the activities, responsibilities, um, responsibilities, and like, and any other updates that you make. So you can see this is a specific migration here, basically handling an add column and some as well. Migrations can be either applied or reverted, right? Now in that they have a up and a down function. So in applying a migration, basically you run the scripts to be able to go onto the database to reflect that. So I want to create a database, I run the migration to create that table for it. But say for instance, what if I wanted to undo that change? Now to think about it, we'd actually go ahead and write a script for that. Now the beauty with migrations is that you can actually revert that with just one line of code. And this is what the down function specifies right here. So you can see the down function actually says, well, we're adding a column here. So what we're going to actually do is remove the column with the responsibilities and activity ID, all of that. So it does everything seamlessly with, say, for instance, one line of code that I'll be probably showing you from the documentation here for SQLize. But yeah, this is what it is with working with the RM. It takes a bit to get into, but once you get into it, it's really fluid working with it. And another thing is that when you're working with it as well, don't make it detract from your actual knowledge. If it is that you're somebody that is database oriented, don't let it detract from that knowledge, because a lot of that informs what it is that you actually write here using SQLize or any other RM for that matter, whether it is that you're using .NET or the like, right? So just bear that in mind. But yeah, that's pretty much it for migrations. It's the same song and dance for these. And yeah. And we went over models. So actually go into routes now. So routes are just basically defining what the routes for the various requests are for. So in each and every route file, you'll find a similar setup for declaration here. First, we declare express. And the reason why we declare express is to be able to get a sub object from that to define, which is called express router. Now with express router, that basically allows us to take and map various routes in the fashion that you see them right here, and then actually pass them back to the index file that you would see right here. So in module.exports equal router, this basically takes this entire file, brings it back to the index.js that I showed you before. And then if it is that you were to require the route itself and store it here, that's basically all the routes for authentication, all the routes for user, and so on, right? So that's basically what router does for you in that sense. So you can see all the routes here are defined. post routes, get routes, patch routes, delete routes, all CRUD, and anything specific that you might want to request to do. It's the same thing for auth and responsibility and user, right? And all of these functions right here are separated into the actual controller folders. Now, this is a controller for activity, which basically defines the actual functionality for what this request is supposed to do. So just to recap, going back to routes, we see that this is the activity route, by the way. It's doing a post, and the route for that post is just basically the /. And then we actually call the activity controller create activity. Now going into this, we end up over here, which is the actual create activity. We just broaden that. But starting off, we start off with a try catch block and some debugging that's happening right here. But essentially what this line of code is basically doing is taking from sequelize. Now you can see here that we define a const model from the models folder. You can see here we actually specify what it is. It's coming from Talawa API models index. And that was the auto-generated file that I showed you in the models folder that's over here. So basically it takes that instance of sequelize because everything has to come back from one instance, which is defined here for sequelize, and using it within this route handling right here. So going back to activity, we actually await a count for the from the database, and we want to say that and this is general sequelize syntax for handling how we're defining this query, because as I said, for sequelize being an ORM, translate the code that you write right here into a subsequent query that is run on the database, and then takes whatever responses so you can use it within a JavaScript code, right? So all this is JavaScript, don't worry about it. But also one thing to mention as well is that this is an entire asynchronous request, given that sequelize is a promise-based ORM. So all of this has to be done asynchronously. So we're awaiting this. As you would have seen from the Talawa app, we had awaited that as well. So this is where the waiting process comes from. So we're counting this, and whatever number is returned right here, we store that. And the same thing we do for user. Now we're doing some logic right here to say that if the activity count is that, we're going to be throwing an exception to say that that user already exists, because remember, this is a create activity function and requests in total. If it is that that user already exists within the system based on the title, or sorry, not user, but activity. If the activity exists based on the title, we don't want to store that again. That's a duplication. So we basically return that, and the system picks it up as need be. Similarly, for if it is that we're trying to add, because the logic with adding activities is that a user has to be added to the activity. Think of it like WhatsApp. If you're creating a group, right? You don't want it to be a situation where you create a group and you're not a part of the group. That doesn't make any sense, right? So this is where this logic comes into play. So if that user doesn't exist, we're just not creating that activity. From there though, everything is a green light, and we go ahead and actually await the creation of the activity. So this is actually creating an activity record in the database using these values that was sent over from the request. So the title, description, the date, and then we take those, again, some more debugging, and then we actually go ahead and create the user, the linkage between the user and that activity. So we're saying that we're creating an activity, and then we assign the user to that activity, right? Then the actual request, now we're setting up something to return the oh no, we're not doing that yet. So essentially we're adding the members that are a part of that group if you were to add more than yourself. Because yourself is added by default, but if it is that you want to add more users to that activity, this is where that is done. So it basically takes that number of persons that were added and then um, adds them in series. But yeah, that's pretty much it. If there are any errors that it throws the relevant exception, and we go ahead and return a 201 or 201 specify that a resource was successfully created, and then return the appropriate message. So we're saying activity and the name of the activity was successfully created. Is that none of that was gone through, we returned a 409 with the relevant message. And you can see that the same thing is done throughout the entire activity controller for all of the CRUD functionalities and specific functions for the application, as well as within the auth. You can see the auth is just two things: register and login, responsibility, and the user controllers, right? And yeah, last thing I think to touch on is there are two things. So firstly, this is where socket is implemented. For socket, as I said, this is one of the more new additions to the project in handling note management. So with socket, it's based on streams, so it's never a thing where yeah, there are two types of requests, you could say. So you have basic HTTP requests, and then you have actual streams. Now with streams, they're typically not closed unless you define that they're closed. And again, this is a lot of methodology to get into. I don't think it would be in the good respect of time to go through that right now, but just know that a lot of this is socket handling the nodes for the application. So for a person connecting, joining an activity, and sending a note, receiving a note, all of that is being handled right here. But yeah, finally is middleware. Now, middleware is basically handling the JWT aspect that I had made mention before in the Talawa Flutter application. So this is essentially just handling all JWT processes, taking whatever request header is sent over. The token itself is then verified based on the key that's defined in the node one, and this is just basically a configuration file for Express itself. You can have other variables that are defined here as well, but essentially just takes that and then appends that to any request that you're making. So this is a good way to actually handle stuff like middleware if you were to be handling like authorization and authentication expressively throughout the app itself. So yeah, that's pretty much it for the server itself. Yeah. Any questions? So, no questions.
No questions from me, but thank you for going through the structure as it is now, and explaining to the students and everyone how it's built out.
Yeah. All right. No problem. And I guess that wraps it up for me here in regards to the code review. And again, as I said before, I do wish that you have a pleasurable experience working with this application.